All right, so here we have this question from our review. Betty and Bill are part of a team of 10 people. Find the probability that Betty will be selected to be part of the 5-person defense and Bill will not. Okay, so this is how I thought about it. I thought since we're looking at this situation, it doesn't say that order matters. As long as people make the team, or Betty makes the team and Bill doesn't, we're in good shape. So what I thought about this was as the first thing is that Betty needs to be chosen. So there's only one choice. I'm going to choose Betty from one person, Betty, and so multiplication. I'm going to choose 4 people for the rest of the team, but those people are being chosen from not Betty, not Bill, and so that means they're taking 2 people out of the mix, so there's 8 choices to choose from which to choose. And so for this thing, out of the total possibility of 10 people choosing 5 of them, so we're still sticking with that idea of desired over total. So in class, we were having a hard time with this because people were saying, well, how do we go through and do that same, arrive at the same answer, but not use combination because that's not the way I think. I'm like, okay, well, what we talked about was if Betty's being chosen, that's one person for the first slot, and then not Betty, not Bill, there are 8 choices for the second, 7, 6, 5, until I have all 5 positions, right? Over, and we can see that there is... for the denominator, there's going to be 10 choices for the first slot, then 9, then 8, then 7, then 6, right? And so, but the issue is that these 2 things don't actually give the same value. When we type the one in the calculator, it gives us something along the lines, I think 42.07% or something like that. But so I was trying to reconcile how do I make those 2, how do I adjust that my thinking for that one on the right, because it seems like it should be logical, right? So I took a look at breaking down the expression on the left-hand side in terms of the formula. So 1 choose 1 is just 1, right? And then if I apply the formula, it's 8 factorial over 8 minus 4 factorial, 4 factorial, all over 10 factorial over 10 minus 5 factorial, 5 factorial, right? Okay. That's just kind of the expanded version of that. Right, so if I actually go further than that, and I actually start to break it apart into undoing the factorial here, I'm going to go ahead and break this thing down until I get to 4 factorial, because the denominator here from that fraction up top is going to be 4 factorial, 4 factorial, and I can see before I do any work here that 4 factorials are going to cancel. Still have 1 in the denominator, but at least I chipped away at it. I'll do that same thing down here for the denominator, 9, 8, 7, 6, and then 5 factorial. Remember, I'm stopping there again because I know that the denominator is going to have a 5 factorial, actually 2 of them. So I see this thing here, so I can cancel those 5 factorials. Okay. Now keep in mind, now I have a fraction within a fraction, so if I want to go ahead and smooth things out a bit, just to simplify it, I can multiply the reciprocal, or the fraction up top by the reciprocal of the denominator. All right, now I'm going to expand this one out here. So that would be 5, 4, 3, 2, 1. Over 10 times 9 times 8 times 7 times 6. And as I look here, 4, 3, 2, 1 cancels with this one over here, and I end up with something that's very similar to what we had on the right-hand side, which is going to be this expression here, but I also have this extra 5 that I'm multiplying by, this one over here, so times 5. So I got to thinking like, okay, well, why is that? Where is that coming from, right? This problem up here at the top, the way we did it this way, this is assuming that order matters, right? Because we're saying with this thing that Betty has to be in the first position, and then we're choosing the other positions in order right there. But order doesn't matter for this problem. No, there's no mention of that. So Betty could be in the first position, or the second, or the third, or the fourth, or the fifth. So that means that there are 5 versions of this expression right here. And so remember, with or and probability, that means plus, right? So doing this thing, adding it together 5 times, is the same thing as multiplying by 5. And there you go. That'll be the formula we're looking for. So either way is perfectly fine. Good luck.